Today we start with a new concept, what you call operators. See, if you learn operators in C language, it is very easy for you to understand Java operators, or Python operators, or any other operator. See, operator performs some kind of operation on operands. For example, if you say 2 plus 3, A plus B, see, plus is known as an operator, plus is known as an operator, and A and B are operands. Plus is an operator and AB is a operand. A and B are operands. In general, we have various categories of operators in C language, that is arithmetic operators, relational operators, increment decrement operators, logical operators, conditional operator, isn't it? Special operators, other operators, bitwise operators, and so forth. Let us start with one component, what you call arithmetic operators. As you know, arithmetic operators are the operators which can be used to perform some kind of arithmetic operation such as addition, subtraction, multiplication. You have to use asterisk symbol, star symbol, multiplication, and then division. That is, there are two operators here, division and modulo division, and this is division and modulo division. Percentage, we used to call percentage, it's a modulo division or modulus. Let us go through one by one. You know, 2 plus 3 is equal to 5. 2 plus 3 is equal to 5, it's addition. And 10 minus 3 is equal to 7. And 4 into 5 is equal to 20. And you have to learn what is the difference between division and modulo division. Listen carefully. When you write 10 by 2 and 10 percentage 2, see 10, this is 2, 2 5s are 10, remainder value is equal to 0, coefficient is equal to 5. When you write 10 by 2, you will get coefficient value. 10 percentage 2, you will get remainder. Remember, very important point. Many programs are completely associated with this logic. There are two elements. Number one, percentage. Second one is by division. What is 10 by 2? 10 by 2 is equal to 5. How do you get? If you divide this, you will get the value, what you call 5, called a coefficient. Remainder value will be acquired. For this, we have a remainder that is equal to 0. Remainder value is 0. This is the difference between this. So we are going to write a program on arithmetic operators. Let us see one by one. So start with comment line. As you know, comment line, header file inclusion. Then there is a main function. In the case of online program execution, we use integer main. Whenever you write integer, you have to return the value called 0. I am taking two variables, A, comma, B. If you want to take more number of variables, for addition, you require add. For subtraction, you require sub or something like this. So you may use or without using this. So the first statement is a printf statement, printf \n, enter any two numbers. What is that? Enter any two numbers. Or you may write enter A and B values. That is your wish. That is totally your wish. Enter any two numbers. How to read it? If you want to read it, what is the statement you require? Scanf. This is input statement. What type of variables they are? They are integer variables. So what to do? You have to write %d, %d, ampersand a, and ampersand b. I told you, ampersand is nothing but address of operator. Here, printf \n, some value is equal to, or you may write addition value is equal to %d. You can directly write a plus b. Printf \n, difference value is equal to, or subtraction value is equal to %d, double quotient, comma, a minus b. Printf is totally output statement. The multiplication value or a product value is equal to %d, a into b. I told you a asterisk b. Printf \n, division is equal to, division value is equal to %d, a by b. Printf \n, modulo division value is equal to %d, a %b. Then close. This is the program to perform. This is the program to perform displaying or finding arithmetic operators value. Let us start with the program. I told you integer a comma b. You have to read two numbers, enter any two numbers, or you may write enter a and b values as well. You have to read it. How to read it? By using a scanf. All these two variables are integer variables. That's why I am using a format specifier. The format specifier is %d. If you are trying to read floating point values, The format specifier may be percentage F. Yes. Here, printf \n some value is equal to or some value is percentage D. What is the sum? A plus B. This is directly A plus B. Printf \n subtraction or difference is equal to difference value is, again it's a percentage D, A minus B. Printf \n product value is equal to or product value is percentage D, how? A multiplied by B. Printf \n division value is equal to, again percentage D, double quotes end, comma, A by B, isn't it? Printf \n modulo division is equal to, modulo division value is percentage D, double quotes end, A percentage B. Everything need to be ended with a semicolon. That is a common process. Every statement should be ended with a semicolon. This is the header file. When you execute the program, see this, it shows error. It shows error. What is that error? Main. Error expected identifier or brackets before token. See this? In this line, fifth line, A comma B ended with a semicolon. But what I did, I added unnecessarily comma. Is it need? Is there any need? No. When you execute, yes, it displays two values. 10 is one number, 2 is another number. Tell me what is the first one? Whenever it displays, it reads two numbers, 10 and 2. Printf, some value is what? Percentage D. What is percentage D? Integer. How to get it? A plus B. What is A value? 10. What is B value? 2. 10 plus 2 is equal to what? 12. Difference value is percentage D. A minus B. What is A? 10. What is B? 2. Difference value is 8. Product value is A into B. What is A value? 10. What is B value? 2. 10 into 2, 20. Division value. I told you difference between division modulo division. 10 by 2. What is that? 10 by 2. 10 by 2 is equal to 5. 10 percentage 2 is equal to what? 0. You got it? This is very, very important point. If you understood the difference between percentage and division, then only you are able to execute some other programs in future. So if you give any other 20 and 5, anything, if you execute the program 10 and 3, listen, 10 and 3, 10 plus 3, what? 13. Difference is 7. Product is 30. Division, 3 3s are 9. Coefficient value is 3. That is a division. Remainder value is remainder 1. In this way, you can execute the program. This is the program for performing arithmetic operations. This is one logic or a direct logic. Some other logic. For example, I am going to utilize different variables for these program elements. For example, for finding addition, I am using sum, subtraction, sub, for multiplication, mul, for division, div, for modulo division, mdiv. Once you read the data, we are going to produce sum is equal to a plus b. Then what to print? Here, instead of a plus b, we have to print what? Sum sub is equal to a minus b. Every statement should be ended with a semicolon. Instead of a minus b, you have to write sub mul is equal to a multiplied by b. Instead of direct writing, you have to use these variables. Division is equal to a by b. Here you need to write div a by b. M div is equal to a percentage b. That is m div. This is the program. You can get the same output, 10 and 2, but only the difference is here I'm utilizing more variables. What is that? More variables. So that here we can get some value easy, or you can take add, or you can take C. But whatever the variable you are taking, those variables must be easy to identify its meaning exactly. For example, in order to add two numbers, you generally use add or sum. If you write XYZ, that may not have, that is correct, no problem at all. But it may not convey any kind of correct meaning to the user. All variable names should be easy to understood by the naive user. This is one. Next, move on to the next concept. Here we move on to the next element, what you call, say this, important concept, control structures. See, I'm not going to follow any kind of order. Whatever the order we have, that always gives you correct information. That means whenever I have an element in the terms of correct meaning or correct order, I'm going to follow that order, right? See this. Control structures. Very important. The same topics will be covered in under C++, even Java or Python with a little bit syntax differentiation. These are also called as control sequence structures, control statements. Basically, control structures can be divided into branching statements. Second one is looping statements. Branching may have conditional branching, unconditional branching. Little bit later, we will discuss about conditional and unconditional. Basically, there are two categories of statements. Number one is branching statements. Again, they are also divided into simple branching, multi-way branching. Second one is a looping statement. Looping statements are also called as iterative statement, repetitive statements. Listen. In the case of branching statements, we have if statement and switch case statement. Generally, if statement may have multiple number of forms: simple if statement, if else statement, if else if else ladder, nested if statement. We will see those formats later. Switch case statement. Whereas looping statements are concerned, iterative statements are concerned, while, do while, and for statements. We go through even initially the program execution. I want to explain you in the terms of a flow chart. In the case of a flow chart, we tested the condition Is it A is greater than B? There are two alternatives, yes and no. This is called as a branching statement. Whereas, based on condition or something, we are going to execute the same set of statements repeatedly. The same set of statements are repeatedly executed. This is called looping statements. I told you, in the case of our flowcharts, draw a flowchart to print 1 to 10 natural numbers. The same set of statements are executed repeatedly, called as looping statements. We are going to test the condition. If it is true, it executes one particular part of action. If it is false, it executes another part of execution. Let us go through branching. Here, in the case of branching, I'm talking about if statement, if else statement, simple if statement, and if else statement. No capital letters are allowed, only small letters. Here the syntax. What is the syntax? Format. If there is a condition or expression, if it is true, immediately a statement will be executed. For any kind of control structures in C language, if we have only one statement, there is no need to open and close. If we have more than one condition, more than one statement to execute, if we are going to test the condition, here I have multiple number of statements to execute. Statement 1, statement 2, statement 3, and so forth. Whenever you have more number of statements to execute, that must be enclosed in open and close. In the case of if else, also the same thing. If there is a condition, if the condition is tested, if it is true, a statement or a set of statements are executed. I told you, if you have only one statement to execute, there is no need to have open and close. Else, if you have only one statement to execute, there is no need to open and close. But if you have more number of statements to execute, there should be open and close. Let us see. I want to find biggest of two numbers. I want to find the biggest of two numbers. See, what is the program? You have to write integer. There is a main function that should be opened. I want to find biggest of two numbers. Then what you require? Two integers are required. Then I'm writing printf \n. It's a format escape sequence which can be used with only printf statement. Enter any two numbers. You have to enter two numbers. It's a printf statement. You have to read it by using input statement. Here the format specifiers are %d because we declared a and b in the form of integer. And then we need to test the condition. How? Everything is small letter. If, what is the condition? A is greater than b. In no loop, if condition may not be ended with a semicolon. It's a condition. If it is true, use a tab so that format will be very easy. %d is bigger or largest number. That is your wish. What is %d? A is bigger. If you write A is bigger in double quotes, output will be A is bigger rather than given number. If it is not true, else what happens? Printf \n %d is bigger double quote send, comma, B. That's it. This is the program for finding biggest of two numbers or largest of two numbers. Even we did it in the case of flowcharts also. Now, how to execute? How to execute? Listen, I'm taking this program. I'm writing integer a comma b, printf \n, enter any two numbers. I told you, you may use uppercase letters or lowercase letters in the case of printf statement within the printf. Format specifiers are %d because we have two integers. Then immediately we have to write the condition. What is the condition? If condition. If a is greater than b, then what happens? Printf, here I'm writing \n, a is big. For example, if I write a is big, if it is not, else printf \n. What is that? Printf \n, b is big. That's it. If you execute this program, for example, whenever we have a %d here, you have to write its corresponding variable. When you execute, you enter any two numbers, 10 and 5. What it displays? A is big. Is it conveys any kind of correct meaning? No. That's why what I'm doing is %d is big, that is a. %d is big, what is that? %d is big, what is it? Its value is b. When you execute, what happens? 10 and 5. 10 and 5. Now the output is 10 is big. Got the difference? Got the difference? In the case of a is big, output will be a is big. When you write %d is big, which means that its corresponding value will be printed. This is the biggest value. If you want to find smallest, how to find? When you keep a is less than b, %b is smaller, %b is smaller. When you execute the same, if it is 10 and 40, which one is smaller? 10 is smaller. For example, we need to execute the same. See, every time you need to have another program, what you call in this case, right? Say this. Run the program, enter any two numbers, 20 and 40. What will be printed? 20 is smaller. If you write a is greater than, I told you in the case of flowcharts also, you have to read two numbers and print the smallest value, a is greater than, a is less than. If it is biggest, a is greater than. So I told you, when you write a is big, it may not convey correct meaning. You have to write %d. What is %d? Its corresponding value a will be. Its corresponding value a. What is a? Here 20 is smaller. If you execute the same program, 100 and 50, what happens? 150. 50 is smaller. What is that? 50 is smaller. In this way, you can find both smallest and biggest of two numbers. Now you have to try it. I'm going to give you an input, what you call a given number. For example, n acts like an input. For example, n is equal to 10. N may be -7. I want to check whether the given number is a positive number or negative number. How many numbers you need to read? Only one number. printf enter any number, and you have to use scanf %d %n. Okay, you have to declare the variable what you call integer n in the main function. Printf enter any number. Here I'm testing. If n is greater than 0, how to verify whether the given number is a positive or negative? If the given number is greater than 0, then what happens? The given number is a positive number. %d is a positive number. What is %d? N. If it is not, n is not greater than 0, which means that else what happens? N is not greater than 0, then given number, you may write the given number %d is a negative number. What is that %d? N. Okay, this is another program you have to execute. One more program. I will give n is equal to 10 or n is equal to 5 or any number. I want to test this is positive number or negative number. A program to verify whether the given number is positive or negative. I want to check whether the given number is even number or odd number. I want to test whether the given number is even number or odd number. The same way, you have to read the number. In the if condition, how to test whether the given number is even or odd? N %2 is equal to. See, in the case of C language comparison, we have to use double equal to. That is, in terminology, we call equal to. If a given number is divisible by 2 exactly, then that is a even number. Printf %d is even number. What is the given number? N. If it is not divisible, printf %d is odd number. You can write the complete. What is %d? N. Okay, that's all.